An airburst is always announced by a brilliant flash of light, many times brighter than the sun, which dies out gradually with the formation of a large ball of fire. The fireball is shown here in various stages of its growth, from a time of less than 1/100th of a second to about 1/10th of a second, when it has nearly reached a diameter of 300 yards. The temperature, which is in the neighborhood of 1,000,000 degrees at first, then drops rapidly to about 2,000 degrees, 1/100th of a second later. At this point, it starts rising again and reaches a second maximum of about 7,000 degrees, then cools gradually until all the heat is dissipated. It is during this rise in temperature that the bomb does its thermal damage. The rapidly expanding fireball creates a shock wave in the air, which moves out in all directions from the point of detonation. This shock wave consists of a positive pressure phase, in which the air pressure rises sharply to a peak, which may be several times atmospheric, then drops rapidly but more gradually to atmospheric, and the negative phase, where the air pressure drops below atmospheric. The negative phase is about 3 times the duration of the positive phase, but much less in magnitude. When the shock wave strikes the surface of the water, it is reflected back. This reflected wave is not as strong as the original wave, as some of the energy is transmitted into the water. As far as degree of curvature is concerned, however, it is identical to the original wave. As the incident wave moves outward over the water, the reflected wave merges with it to form a super shock front, which may be several times as strong as the incident wave in free air. As the shock front moves out with the negative pressure phase close behind, a condensation cloud may be formed. This is caused by the rapid cooling of the air due to the expansion during the negative phase. If the relative humidity is high enough, the cooling of the air may cause the precipitation of small drops of water, forming a dense cloud or fog. When the negative phase has passed and the air restored to its normal pressure and temperature, the cloud quickly dissipates. The fireball, being a mass of extremely hot gases, is very buoyant, and within a few seconds starts rising at a speed of several hundred feet per second. A rising column of air is formed under it and continues for several minutes after the blast. As the fireball rises, it cools rapidly, forming the familiar mushroom cloud. As nearly all the fission products of the bomb are contained within this cloud, it is highly radioactive. However, due to its upward movement as far as personnel on the surface are concerned, the nuclear radiation does not last much more than a minute after the burst. The atomic cloud continues its upward rise, much like a billowing thunderstorm. It may go as high as 50,000 to 60,000 feet, depending on atmospheric conditions. At this altitude, a distinctive ice cap may form, caused by condensation and immediate freezing of the moisture in the air brought up from lower altitudes.